So for these examples, we're going to use a quadratic formula and then work out the decimal values, and then we're going to confirm these decimal values from the graphs. So here we're going to again use a quadratic formula. So x is equal to negative of negative 5 plus minus square root of negative 5 squared, which is positive 25, minus 4 times 3 times negative 8. And that's all over 2 times 3. So we get 5 plus minus square root of 25, negative is positive, 12 times 8 is 96. That's all over 6. So we end up with 5 plus minus 121 all over 6. And 121 is a perfect square, so we end up with 5 plus minus 11 over 6. Okay, so we get 16 over 6 as one solution, and negative 6 over 6 as the other solution. So we end up with, well, that's going to be 8 over 3 and negative 1. Okay, so when we graph this, we want to check this over by graphing. Okay, so when we graph this solution, the graph of this is going to be a parabola facing up. So sketching the graph here. And from our graph, we're going to get something that looks like this. And we get negative 1 as one of the zeros. Okay, so I'm just using decimals right now, so I can just touch on the roots. And I get 2.667, or 6 repeating as the other solution, and that's going to be the same as 8 over 3. Okay, so our graph does confirm our solutions here, and we can solve our quadratics by graphing. The difference is we have to rely on decimal values whenever we graph these, because they don't give us exact values. So same thing here, we're going to do solve for x by using the quadratic formula. So negative b plus minus b squared minus 4. Remember that the a has a negative on it, so negative 2. And that's all over 2 times, again, that's going to be negative 2. Okay. Simplifying this expression, we get 25 plus 80. And that's all over negative 4. And we get negative 5 plus minus square root 105 all over negative 4. Okay, so then working out the decimal values for this, okay, we're going to end up with so negative 5 plus square root 105 divided by negative 4, and I'm getting negative 1.31. Okay, so it's negative 1.31 is one of the decimal values, and I'm going to do the same thing, except now it's going to be negative 5 minus the square root of 105, and I'm going to get positive 3.81. Okay, so those are my decimal values. So when I go to my decimals and I graph this now, I have an upside down parabola. Okay, so the negative coefficient, leading coefficient indicates that, and it's going to look something like this. It's going to go up and come back down. Okay, so when I go to my decimals and find my roots, okay, I get negative 1.312, okay, which is what I've got my decimal value that I calculate algebraically from the quadratic formula, and 3.1812. Okay, so my graphs do confirm my quadratic formula, and again, these things are always connected. The difference here is that with the quadratic formula we get exact values, which we could convert to decimal values, our graphs only give us the decimal values.